Good afternoon, folks. Today I'm gonna be making a screencast of Educational Codeforces Round 107. It's a kind of experimental content for this channel, but I'll try my best. I'm gonna solve as many problems as I can, and I'll explain them in detail, so I don't know, write in the comments if you like it or not. Maybe I'll do some more in the future. So the contest started. We've got the first problem, review site. You're an upcoming movie director and you have just released your first movie. You have also launched a simple review site with two buttons to press, upvote and downvote. However, the site is not simple on the inside. There are two servers, each with its separate accounts for the upvotes and the downvotes. And reviewers enter the site one by one. Each reviewer is one of the following types: has watched the key like it, okay, watched disliked it, hasn't watched, they look at the current number of upvotes, and decide if there are more downvotes than downvotes, otherwise okay. Since you have two servers, you can actually manipulate the votes so that your movie gets as many upvotes when a reviewer enters the site. You know their type, and you can send them either to the first server or to the second. What's the maximum to the number of upvotes you can gather over both servers if you decide which server to send each reviewer to? Okay, I got it. So it seems to be kind of straightforward. Let's open Sketchbook. So the problem is we've got some people. Some of them like our movie, some of them dislike our movie, and some people don't know. And we can send them to one of two servers, and on each server there are, for example, A people that liked it and B that disliked it. And if a person likes, he just presses this like button. If a person dislikes the movie, he just presses this downvote button. And if the person doesn't know, he just looks at this number, and if A is at least B, then he upvotes, and otherwise he downvotes. So, and we want to have as many likes as we can. So we can see that these numbers are constant, we can't change them. So we want all the people that don't know right now what they want to do to decide to like our movie, and then we'll have as many likes as possible. So I think we can just send all these question marks to one server and all the other people to this one, and then we'll have as many likes here as possible. All these people will like this movie. Or we can even send likes to this and all the dislikes to that. It doesn't really matter. Let's see, okay. So 1, 2, 3, 1, 1, 1, 1, 3, 3, 2. Yeah. Okay, and we just need to output the total number of likes. So the total number of likes is just the number of likes and the number of question marks. So it's amount of ones and threes in the input. Okay, we have a multitask. We've got n. Answer, we go from 0 to n. We have type, and if type isn't equal to 2, then answer is increased by 1. And then we just output the answer. Okay, let's try our test. 0, 2, 5, 2. Okay, it works. Let's send this task. Yeah, I took a long time because I was explaining everything, but I'm pretty sure it doesn't really matter how fast do we do it. Okay, problem on GCD. You're given three integers, a, b, and c. Find two positive integers such that decimal representation without leading zeros consists of a digits, b digits, c digits. Okay. Outputs x and y. Oh, very interesting. And a and b isn't bigger than... Huh. I got it. Okay. Okay, accepted. So, we want the first number... Okay, we want the first number x to be a digit, y to be b digits, and GCD of x and y to be of c digits. Gotcha. So I think we should start with choosing this number. Let's say it's z. And then we want to find two numbers that are divisible by z. And have this amount of digits. It should be easy, but I don't see right away how to do it. Actually, there are like 9.9 multiplied by 9 is less than 1,000 different inputs, so we can just pre-calculate all the answers, but I think it's unnecessary for this problem. Okay, I think we can say that z is just equal to 10 to the power of c minus 1. So it's like 1, 1, 0, and there are c minus 1 zeros. And then we just need to find, like, we can just say that z is equal to 1, and we can subtract from a c minus 1, subtract from b c minus 1. So we kind of just delete all these zeros from all three numbers, and we just try to find two numbers that GCD is equal to 1, and they have a specific amount of digits. Okay. So I think we can just find two prime numbers, right? And it will work. Or we can just take one number. Yeah, we can just take 10 to the power of a minus 1 and 10 to the power of b minus 1 plus 1. And that will be co-prime. Okay, so the final answer is gonna be, we divide it by this, then we should multiply it back. So it's like 10 to the power of a minus 1, yeah, and 10 to the power of b minus c, I don't know, multiplied by 10 to the power of, no, we want 10 to the power of c minus 1, so that we'll have c digit number in their GCD, and then we should multiply it by power of 10 plus 1. So it gotta be, we should add up to b minus 1, so it should be b minus c plus 1. Okay, seems right. And AB are not big, so it should be okay. The number always exists. Okay, let's try it out. So we take this amount of tests, we take A, we take B and C, Then x is equal to 1. Okay, let's just create a function that power is 10. Ans equal 1 for e equals 0 less than x plus plus multiply by 10 to our answer. Oh, I don't want to care about 1-1s. It seems like there aren't any, but I don't want to care. So, okay, so x is equal to power 10 of a, and y is equal to power 10 of c minus 1 multiplied by power 10 of b minus c plus 1. And then we just output these two numbers. Corner cases, let's find out. Okay, so first test will be 1, 1, 1, 10 and 2. Okay, to the power of a minus 1, right? 1 and 2, yeah, it works. Okay, and let's take this 2, 3, 1, yeah, 2, 2, 2, yeah, like 6, 6, 2 seems to work. Yeah, oh yeah, there is this test. Okay, what did just happen? Okay, yeah, I think it's right, so let's just submit it. We're super slow on this contest. It's been 12 minutes and we've only solved 2 problems, but that's fine, that's fine. Yet another card deck. You have a card deck of n cards numbered from top to bottom. The top card has index 1 and bottom card index n. Each card has its color. Okay. You should process Q queries. The gth query is described by integer. For each query, you should find the highest card in the deck with this color. Print the position, take a card and place it on the top of the deck. Got it. Accepted. So interesting. There are at most 50 colors. It should be helpful in some. So we've got a deck and of n cards. Each card has its own color. We have like T, and we want to find the first from the top card that's of this color and put it on the top. And what should we output? Position. Okay, we should output this position and then put it on the top. Right, I got it. So what does that mean? Okay, I think we should just, yeah, let's consider all the cards of the same color. Yeah, let's put their positions into a list. So here is all the cards of color 1. They have like CI1, CI2, and so on. Of color 2, they have CI2 and yeah, CJ1 and so on. 3, okay, it may not work, I don't know, probably doesn't, yeah, because a lot of things change here when we put this card on the top. I'm a little bit sick today, so I'm not thinking straight. Take this card and put it on top of the deck. Okay, it seems like we only care about the top card of every color, because cards of one color don't change their order. Because when you perform operations with different colors, you just move this color to the other place, and order on this card doesn't change. And when you perform operation on this color, you just take first and put it on the first place at all, so it will remain first in this part. So we can just simply have 50 numbers which represent the first color of the first card of each color. And then if we take this card, then this number is 1, and we should increase all these numbers by 1, because we take we should take not all the numbers, but all the numbers that are to the left from its original position. We take this card and move it to here, so all these positions increase by 1, right? Yeah, it seems to be right. And it works in 50 multiplied by n plus q. Actually, just 50 multiplied by q, it doesn't really matter. So let's write the solution. We'll keep track of 51 actually colors, because they are numbered from 1 to 50. So first position, and we've got q. Let's say it's -1, and then we go from the top. I think we don't even need to store the original array. So we got color, and if first position of this color is equal to -1, then first position of this color is equal to I now. Yeah. And then we just perform all the queries. We take the color, then we go through all the colors from 1 to 50, and if first position isn't -1, so there is such a color, and if its position is less than our position, so first position of J is less than first position of color, then first position of J is increased by 1. And there we say that, okay, we should output first position of this color, right? And also we should say that now it's equal to 0. And as soon as they have one base numeration, we should increase it by 1. Okay, let's see. First positions for all the colors, there are 50 of them. We go through them. We store, if we don't have this color ready, then this is its first position. Then we go through all the queries. We take the color, we output its position, yeah, and then we go through all the colors, and if this color exists and its position is less than our position, it's increased by 1, and then our position is 0. Seems to be right. 5, 2, 3, 1, 5. 5, 2, 3, 1, 5. Okay. Let's submit it. problem number 4. Min cast string. Let's define the cast of a string as a number of index pairs such that, okay, I got it. So we want to we define the cast as a number of substrings of size 2 that are equal, right? You're given 2 positive integers on all strings with length n that contain only the first k character, okay, with minimum possible cast. With minimum cast, find any of them. Right, I got it. So it seems to be, okay, yeah, see. So we need to construct a string of size n, which uses only k first characters from the English alphabet, and we want to take a look at all the pairs of neighboring characters, and we want to minimize the number of pairs of equal substrings, right? Interesting, very interesting. And what is the answer here? A, B, A, C, A, D, B, B. Okay, the number is 0. Yeah, it seems like there should be like a cycle in which we like put all the different substrings of size 2, and then we return to the beginning, right? So let's see. Let's say that all the characters, we put them in like graph, and then we can add an edge from here to here, which means that now our last character is this, and then we go here. And we want, and if we have this edge, it means that we have this substring AE, right? And we want to make a cycle, right? And there are like all these different edges, and we want to create a cycle, Euler cycle or something. And also we have this AA. Yeah, but it doesn't really work. I don't know if should work, right? How to find an Euler? I think Euler cycle in this graph should be, we can find it pretty easy. I think it's about, yeah, let's say that every time we are in a new character, we go through a cycle, then we go through this cycle on the outside. Should be easy. Why can't I solve it? Okay, let's take a look at the example with 2 characters. We should just go here, take a cycle, go back, take a cycle. And if there are 3 characters, we've got all these. Okay, I think we shouldn't care about this. We already understood that as soon as we get to the vertex first time, we should just take it and then go on. So here we should go this, and then we should go in the other side. Okay, so the cycle is like this and then the other direction. How are we supposed to to do it right. Because I don't really want to copy Euler cycle code. It should be easy in this case. Okay, we go through this cycle, then we go through like this cycle. And we could go through this cycle here too. Can go through this. Okay, I don't know. Let's just copy Euler cycle algorithm from Emacs. It's a path, not a cycle. I'm really bad at Euler cycles. I don't know anything about them, basically. So what do we have here? Degrees. Yeah. Okay. We add a new edge. Okay, it's just about the path, so we don't need it. Right, and also our graph is, well, we can store it like that. It's not a problem. Let's say it's n, doesn't really matter. Yeah, and then we go through, yeah, and then we say that all the edges are ones, right? There's an edge from any vertex to other vertex. It's about degrees. Let me see. It's about degrees, so it's undirected graph. Well, okay, should work, I think. Anyway, well, okay, first is equal to 0. We don't need this. We don't need this. We know that there is a cycle. Right? So, well, not empty. We take the first. We take the first edge. We add it. We shouldn't do this. E is equal to n. Ah, okay, I got it. I got what does it mean. We add it to the, yeah, wow. And we delete it. Okay, I think it should work. So we've got our cycle in result. And let's say, and also we have this variable n, which now we should call something else. string length, and as soon as the size of our result is less than string length, right? And we should for e from 0 to string length, we should just output this in a cycle, right? Oh my god. We output a plus result I percent size of result, right? And then we output the backslash n. I'm pretty sure that there should be a solution without Euler cycles, but I don't know it. Okay, first of all, let's see our cycle. Okay, so let's say 9, 4. What is gonna happen? 0, 3, 3, 2, 2, 3, 1, 2, 1. What? Let me take it 0, 3, 3, 2, 2. Okay, let's make smaller one with 2 characters. 0, 1, 1, 0, 0, right? But with 4 it didn't work, I think. 0, 2, 2, 1, 1, 2, 0, 1, 0. It works. And what about... it didn't... yeah, it didn't stop. Yeah, I got it. And also there is 0 at the end and they don't need it, so we should say pop back. So, because it's a cycle, right? Character. Got it. 9, 4. ADD CDBCA. One, 2, 3, 4, 5, 6. Yeah, should work. 5, 1. 5, 1. 10, 2. ABB. ABB. Okay, yeah. Seems to be correct, but maybe too hard for this problem, I don't know. I wanted to come up with an easier solution, but it's educational code forces, maybe it's about Euler cycles. Runtime error 38, oh my god. Yeah, I popped back to it here. Maybe I was wrong. Less than plus 10. I don't know. I percent. Yeah, because it's the size of 0. Yeah. It's about that. Oops. Okay, let's resubmit it and go to the next problem. This modular, maybe it's about FFT, but probably not. Have a large rectangular board which is divided into n multiplied by m cells. Okay, it was correct. The board has n rows and m columns. Each cell is either white or black. You paint each white cell either red or blue. Obviously a number of different ways, yeah. After painting the white cells on the board, you want to place the maximum number of dominoes on it. Scored by at most 1. If the domino is placed horizontally, it should cover only red cells. If you don't, oh, okay, I got it. Yeah, so we wanna, so black cells are just, we can think that they just don't exist, right? The value, calculate the sum of values of what? Ah, yeah, okay. So we want to find the number of ways. No. Let's value on the board maximum number of dominoes. Calculate the sum of, okay. We want to find the total amount of maximum dominoes, right? So we've got some black cells that we can't use. Also, we've got some first white cells that we can, let's say they are a little bit gray. These are white cells. And we should paint white cells into red and blue so that we want to place some dominoes like this, and find, oh my god, I don't understand this problem at all. But at most one domino, place horizontally, red. Yeah, makes sense, but seems to be kind of hard, I don't know. Okay, these are black, these are white. And multiplied it by m. Oh, constraints are kind of big. Huh. Yeah. Okay, here we can figure out what's going on. There are 8 different, of course there is like at most one domino, and it's either horizontal if these two are red, or vertical if these two are blue. So it's bad if this isn't equal to this or this, right? Then it's 0. But there are only 2 variants. Should be red, and these 2 should be blue, or these 2 should be red and this should be blue. Otherwise we can put one domino. Why isn't it 6? Let me think about it. We've got 3 cells, right? If these 2 are red, it's bad when these 2 are red, right? So we are okay about this, we're okay about this, we're okay about this, and we're okay about this. Yeah, there are 4 variants in which we have answer 1, and all the others have answer 0. Damn. It's hard, I don't know. So let's think that we already have the coloring. What's the biggest amount of dominoes we can handle, we can put on the board? Yeah, it seems like blue cells don't have to do anything with red cells, and for red cells we can just say that, okay, as long as there are some red cells, let's just pack them into dominoes from left to right or something. Yeah, let's just go from left to right, top to bottom, and if we have 2 cells and they are not taken at the moment, we can just take them as a domino. Okay, yeah. And the thing is, for each pair, yeah, we can look at this from the other direction. Let's not count like let's not summarize all the CNTs from all the how can we call it? I don't know, covariance. We can find for each domino amount of covariance in which it's taken, right? So in which covariance do we take this? It should be red, it should be red. And what should be going on with all the others, right? We don't really care a lot. The only thing we care about is that this isn't paired with this, right? So if we take a look at, so if it's blue, it's okay, right? But if for example it's like blue, red, 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 then we'll pack it like this. So we want to have like even amount of reds to the left before we have blue color. Or maybe not blue, or maybe, okay, blue or black, right? We will find this number and then we'll just transpose our matrix and solve the same stuff for vertical dominoes. What is this number? Let's find out. So if we have two cells, there are a bunch of white cells and then there is a black cell. So we are okay about if it's blue, or if it's red, red, blue, or it's red, 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 blue, and so on. If there are let's think about it in terms of probability and not amount. Yeah, what is the fraction of the covariance in which we are okay? So it's okay in 1/2. In 1/2 of the variance, it's blue. This is okay in 1⁸. It's okay in 1⁵, and so on. So we calculate the sum of odd numbers, odd powers of 2, as soon as 2i plus 1 isn't bigger than k, where k is the amount of numbers here, right? Yeah, should be fine. Should be fine. Yeah, and then we multiply it by 4, 1/4, which means that these two should also be red, right? And then we summarize it, and at the end we multiply it by 2 to the power of white cells. Okay, seems to be correct. And we summarize it over dominoes, and we can pre-calculate it for all the numbers of k from 0 to like n, multiplied by m or something, yeah. And we're gonna be fine. Yeah, it should work. Let's see, what do we have here? Okay, problem E. It's a little bit trickier than previous ones, but not that hard. Let's make an array of size 3, 1, 2, 3, 4, 5. We'll have, I don't know, let's have reverse powers, reverse 2 powers, and let's call it dp. This is dp k, dp. And first of all, we take n and m, and we calculate this. So to find the powers of 2, ref 2 powers 0 is equal to 1, ref 2 powers 1 is equal to, okay, we can take this modular. There is a little trick where you don't need reverse multiplication. You can just take this number, because this is odd, so if we add 1 it's even, so it's divisible by 2. And if we take this number modulo 2, then this is 0 and this is 1 divided by 2. So the first power is this. Actually, it's just not first power, it's reverse 2. And then we go from 0 to n, from 1 to n, and say reverse 2 powers I is equal to reverse powers I minus 1 multiplied by reverse 2% modulo. And here we take all the odd powers, right? So dp0 is equal to 0, dpi is equal to dpi minus 1, and if I is even, well, wait, is equal to 1, it's odd, then we add reverse power I. Okay, we calculated this dp here. Yeah, and then we should find the answer. First of all, we should take the input vector of strings and we take it as our input. Yeah, we should go run it 2 times. Okay, let's say that ans is equal to solve of s and m. Then we go and say that we have vector of strings. Okay, I think it's easier to have a vector of integers and not care about these strings. String s in s, field from 0 to m, and field ij is equal to sij equal to black. Okay, this is black. So if it's black, it's now 1, and if it's white, it's now 0. And then we go make another field transposed field of size m, and we go through our original field and transpose it. So transposed field ij is equal to field ji, and the answer is sum of from field so for horizontal and transposed field mn, right? And then we should go through our field and multiply it by amount of white cells, right? Or we can do it there, it doesn't really matter. And now we should just output the answer. Cool. But I think we should also take it modulo here. So for horizontal, for our field N and M. We go through all the cells. Okay, let's take this out, not to care about it. So answer is equal to ref2 powers ref2 powers the answer is 0, and then we multiply our answer by ref2 powers 2, and then we go through our field, and if we have a white cell, we should multiply our answer by 2, and then we return our answer. Yeah, I'm definitely not thinking straight today. It's really hard. Okay, let's go. We go through our rows, and we want to count the amount of white cells. There are k plus 2 here. White cells. G from 1 to M. If Fig is equal to 0, white cells plus, else it's equal to 0. And if we have at least 2 of them, we should add to our answer dp white cells minus 2. Right? Seems like that. Should be working, I don't know. Let's try it out. I didn't create functions to add and multiply numbers modular. That's a bad thing to do, but whatever. So the answer is 144 SG. Okay, it doesn't work. I don't want to use debugger here. Yeah, this is it. 16. Okay, it didn't work. How can it be 16 though? Okay, let's try this example. Over here, 0. Yeah, it's bad. It's definitely bad. Ow. No. What? Oh, whoa. Wait. We're also okay about black cell. Yeah, I didn't think about it. So we have these blue, red, red, but we also can have black and then a lot of reds. So yeah, here if white cells percent 2 is equal to 0, we should actually say that we should also add reverse powers of 2 white cells minus 2. Yeah. And now it works. Okay. Yeah. So we only thought about this kind of problems where we have like blue, and we have blue, red, 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 red. But also there is a thing where it's like black, and then there are a lot of reds, and we didn't count it. Because for us, blue and black are pretty much the same, but we don't need to cover it. It's just black from the beginning. Here it's 48, 48, and this is 9, 9. Cool. It's problem E. Yeah, it's kind of slow. Wow, 72 people solved. Oh, yeah, okay, it's this problem. I thought that we just solved D and 72 people solved F. Okay, these problems aren't being solved that well. Seems like it's gonna be accepted. There are 2 problems. Okay, accepted. F and G. Got it. Let's read F. Chain word is a special type of crossword. As most of the crosswords do, it has cells that you put the letters in. Some sort of hints to what these letters should be. Let's find out what's chain word. Okay. Or put in a single row. We will consider chain words of length m in this task. Each chain word is a sequence of segments. Segment don't intersect with each other and cover. Oh, okay, yeah, it's just words. Segment contains a description of the word. Yeah. Okay. There are actually 2 hints. One sequence is the row above the cells below. Okay, you're provided with a dictionary of n words, each consists of lowercase. Chain words following triple. A string of m lowercase Latin letters. First hint. Such that the letters correspond to singular. Okay, wow, n isn't bigger than 8. Okay, so we've got a dictionary that contains of n not bigger than 8 words, and we want to create a crossword of m characters. So that we want to make a string of some characters, and we want to split it into parts with 2 variants, so that all these words are in the dictionary and all these words are in the dictionary. And we want to find the number of different ways to do it. And and m is at most 10 to the power of 9. It's interesting. No more than 5 lowercase Latin letters. So as soon as we see that m isn't bigger than 10 to the power of 9, we understand that we can't solve this problem in like of m time or of mn. So we probably should use some matrix exponentials. Okay, for example, if we find that this string can be split into words in like k variants, then we should add to the answer this number k multiplied by k plus 1 divided by 2. So we should take like one splitting, we should take another splitting, and we should take all the pairs, right? So we want for every amount of splittings, find the number, and then we should just from k from 0 to infinity, I don't know, the number of splittings from this multiplied by that. Yeah. How can we do it with dynamic programming? We see that none lowercase Latin letters. So every string is of length at most 5. So everything we care about are our last 5 letters. Actually, I would say that only 4 letters. And then we add a new letter and we have 5 letters. Yeah, but we want to go back, so it's not that easy. Maybe we should have 10 letters, but then it's a lot of different letters. Okay, what is 26 to the power of 5? It's a reasonable number. We've got some words in our dictionary, and we want to construct a string. If we have some letters here, we may want to, it's a big amount of letters. We can do it. Oh. Okay, actually, we definitely will have like a permutation of these strings at the end. So there are not a big amount of these strings, right? Yeah. So it's like 8. If we have 10 characters, it's at most 10 of the substrings. So it's at most 8 to the power of 10 or something, which is a big number. But if we take 5, that's not that big. Yeah. Yeah, okay. I don't get it. I don't get it. It should be some matrix exponentials, but I don't understand it. And also the number of splittings can be really big. If we have these two words in our dictionary and we have a string of size m, I think there are more than 2 to the power of m divided by 2 different splittings of a string a. There are a lot of them, because for example, if we split our string into substrings of size 2, we, for each of these substrings, we can either take 2 characters or we can take a substring of size 2. So it's 2 variants for all the substrings of size 2, and there is at least this amount. So it's exponential, it's really big. We don't care about it, so we can't use our formula like sum of k multiplied by k plus 1 divided by 2 multiplied by c and t k. But what should we... That's insane. I don't get it at all. Okay, let's solve the easier problem. There are 2 easier problems. One of them is we want to count just the amount of splittings, not the amount of double splittings. And the other simple problem is we want to just find the number of strings that we can split, not the number of splittings, right? How to solve this problem? It should be super easy, but I don't understand it from a spot. Number of substrings, then split it. So we will have like dp of size and like last digits, last characters, and then we can try to add every single string to it, right? So how many of these do we need? Oh, we really don't care about these characters. We only care about the size. Oh wow. And we don't even care about these. Okay, this is a easy problem. Yeah, it's a simple DP and it's linear, so we can use matrix exponentials. And what about the number of splittings? In this case, we care about the characters, because if we have this string and we add this, there can be like this splitting, and we don't know anything about it actually. Wow, what? Okay, and what if we have a characteristic of our strings and we travel through it? Yeah, let's consider this. So there are, for example, strings BAA, there are string B, and there are strings BA and AB. And we have this string. So we have A, B, B, A, A. And then we travel through our accuracy. We go here, and then we go here, right? This is B. And we know that there are two splittings. How we are supposed to understand it from this? Boom, boom, boom. It's the number of paths. It's number of paths that have this string. It doesn't really make any sense though. Yeah, it definitely doesn't make any sense. Wow, okay, let's go to the next problem. For now, how many people? Yeah, 6 solved this, 15 solved that. It definitely shouldn't be hard, but I can't get it. Alice and Bob have a rectangular board consisting of n rows and m columns. Each row contains exactly one chip. Alice and Bob play the following game. They choose two integers and cut the board in such a way that only the part of it between column L and column R remains. So all columns to the left of column L and all the columns to what? Okay. One of the chips, any positive number of cells to the left. What? Okay, I got it. Wow, it's overcomplicated. So we have like a board. There are some chips. We take a string, and then at each move we can move any chip to the left any amount of points. So it's the problem about game theory. First of all, we can see that these chips are independent, so it's like a sum of the games. If we move this chip, we don't care about other chips, are we? Can there be two chips in the same chips in there? Wait, what? Index of a column. What? There is a columns? And oh, I'm sorry. I thought that we have only one dimension. Second Bob, the third by Alice during the morpher. I don't understand. Why do we... What? I got it, okay. Actually, we can think about this problem as one-dimensional. Because we can just think that chips can overlap, right? Or the eth row is Yeah, I think that's right. So it's independent and it's a NIM game. If there is a chip here, then this length is A, then it's probably a NIM of A minus 1, because at the end it will be here and we can decrease A by any number. So the we should take a XOR of all these NIMs minus 1, and if it's 0 then the second player wins, and otherwise the first one wins. Did I understand the problem correctly? So we split it like that. Yeah, seems like that's right. But I didn't really understand this. So there is a chip in every single row. Okay, yeah. Yeah, it's overcomplicated. You can think that there are no rows at all. There is just a 1D problem, and there are chips in some cells. Maybe they are equal, maybe are not. Yeah, and we should take their positions. Okay, there are some positions here. We should take like A minus L minus 1 and then XOR it. Okay, gotcha. And we should find out if it's equal to 0. So first of all, let's understand that we can take this and subtract it from here or something. Or shouldn't we? I think we shouldn't. There is only a huge good characters. What? Okay. 1 3 3 7 4 2 6 9. Oh my god. 2 and 3. We've got 3 3 and 2. It's a game of 2. The second one wins, right? 1 3 2 2 and 1. The first one, yeah, okay, it seems to be correct. So we should take this for all AIs that are no, minus L actually, yeah, minus L, at least L. Okay, wow. Okay, we can think about all the bits of this number independently, and then we should check if any of its bits is equal to 1 or not. So what about the bit number, I gotta know, the bit X, right? So we should take all the chips that are placed. Let's take our segment. In these 2 to the power of X numbers, this bit is 0, so we don't care about them. In these 2 to the power of X is 1, then it's 0, okay. 0 again, then it's 1. So we should take all these, we should count the number of chips here, and if it's odd, we won, right? Okay. Makes sense. And it's probably it. Like, So if we calculate, we can just calculate for every position and every x this sum to the end of the array, right? And then at some point it ends. And if it ends in a segment, we should just delete this amount. No, we should, we should take this point, subtract it from the answer, and also subtract the amount of bits here. I think it makes sense, right? Yeah, should make sense. Let me think about it one time again to truly understand what am I gonna write here. Okay, seems to be understandable. Let's go. So it's problem G, and first of all, let's check our input. N is equal to 1, 2, 3, 4, 5. We have amount of chips in every cell. Pref sums. 4 int e equals 0 less than n. They are from 1 to m, so we should subtract 1, cntc plus plus t1 from 1 to n. We should add cnt minus 1. Oh no, wait, what? Pref plus cnti, yeah, sorry. What am I doing? I don't know. I'm sorry. Okay, we've got its prefix sums here. Also, we need this dynamic for all the x's and all the positions. We want to know this number. So on the suffix from here, we take all the segments 1, 1, 1, and so on. Yeah. So let's make a function get from L to R, and it will return prefix sums R minus prefix sums L. And now we want to create dp xn. X is equal to, I don't know, 20, let's say. Doesn't matter. So we go for all the x's from 0 to 20. Position from 0 to m. And what do? Next position is position plus 2 to the power of x plus 1, right? So we take two segments of size 2 to the power of x, and there is a next segment. So if next position is less than m, then dp x position plus equal dp x next position. But first, let's say middle is equal to position plus 1 to the power of x. It is this. And we say that dpx position is equal to get sum from middle to next position. Oops. Yeah. Seems to be correct. Okay. So we calculated this dynamic. And now we want to find answer for L, R, and X. So answer is initially equal to dpxl. Then we split it into segments of size 2 to the power of x plus 1. We see where our right position is. Okay, so this position is, let's call it middle. Middle is equal to r minus r percent. No. It's about L plus r minus L divided by 1 to the power of x plus 1. No, wait. It's r minus L percent 2 to the power of x plus 1, right? Yeah, so we have sum of 2 to the power of x plus 1s here and some numbers here. And if this difference is divisible by that number, then this middle is equal to r, right? So we've got this. So then we say that we subtract from answer this stuff. And also we want to have this separator is equal to middle plus 2 to the power of x. And if separator is less than r, then answer should be increased by get sum from separator to r, and then return answer. Answer percent 2, I think. Well, let's say that it's just answer. Then we go through all our queries and we take LR, make it a half interval, and then have one bit false, have one bit Alice, else, Bob. Then we go through the bits from 0 to 20, and if find answer LRX plus percent 2 is equal to 1, then have one bit is equal to true, and we break. Okay. Pref sums. Next position. Okay. n m, right, 7, okay. Middle point, next point. Well, yeah, it's a little bit problematic here. Let's say here that if L is bigger than R would return 0. And here we say minimum of this number and M, right? Minimum of this number and yeah, middle and minimum of that number, yeah. Cool. Let's try again. BBB, AABB. Not correct. So it fails on the second test where we have 1, 3. 1, 3. In 1, 3 we have 1, 2, 3, 3. 1, 2, 3, 3. So we take a look at the first bit actually. The first bit, it's 0, 0, 1, 2, and 2. First bit says us that we have this, and it says that we don't. Interesting. X percent is equal to 1. We have bit 1, right? Yeah. Yeah. Next pass is less than m. Then we add it. Seems to be perfectly correct. If L is more than R, we return 0. Otherwise, we return the difference. Okay. Yeah, seems to be correct. Everything is fine. N, find answer. XL, middle point is R minus. Okay, we should check this definitely. This middle point. We subtract this, and then we go there and add to the answer that part if R is bigger. So in this case, we should just get 1, seems like. Yeah. Should just get 1. So what is this? In our case, we have from 0 to 3. And x is equal to 0. So we take 3 minus 0 percent 2 to the power of 1. So it's 3% 1, it's 1, 3 minus 1 is 2. So our middle point is 2. And our separator is 3. Should be working, I should say. Let's say dpxl, dpx middle. Oops, there are a lot of them. If x is equal to 0. 2, 1. Wow, interesting. Why are there 2 and there are 0? Oh, yeah, I should go from the other side. I got it. Yeah. But it still doesn't work though. What? What? It should have been working from this point. Okay. 4, 2. Huh. Okay. What am I doing wrong? BBB, AA, BB. What am I doing wrong? Let's take a look at this sequence. So we have 0, 2, 2, 6, 3, 1, 5, 8. So we have 0, we have 1, we have 2 2s, 3, we don't have 4, we have 5, 6, and 8. So here, if we have left bound here, we'll take this, we'll take this, we'll take this, and we'll take this. And if our left bound is here, we should be taking these. But it doesn't work for whatever reason. Let me output dp00 and dp02. 3, 2. Wait, what? It works. Wait, it works. What? What's the problem then? 1, 3, 0, 3. If x is equal to 0, out L dpxl middle dpx middle 1, 4, 1, 4. Middle is equal to what? One, 4, 1, 4. I don't get it. What's going on? One, 3, 4, 3, 2. Yeah, makes sense. What? I'm a little bit stupid today, so don't care. 0 and 3, we have 0 and 3. In this case, if we have 0 and 3, then wait. Oh, what did I do? What did I do? Oh my god. Oh my god, how stupid am I? How stupid am I? How did I do it? I subtracted the wrong thing. And it was right all the time. Jesus. Okay. Wow. I'm so bad at this. I'm so bad at this. Wow. Oh, actually I'm not that bad. Let's solve the problem. Do we have enough time for this? Chain words, not Chinese crosswords. Chain words. Yeah, this problem is weird. I don't get it. M is really large, but I don't know how to solve this problem even if M is not large. DM. DM. Yeah. These are huge. What am I supposed to do? We split a string. Yeah, if we have like one splitting, it may help us to find all the splittings, right? Number of splittings, interesting. For a given string, the number of splittings. Yeah, it's easy to count the number of splittings for a given string, but we don't have a string. We have some weird construction, which for me doesn't make any sense. How fast is that though? Yeah, pretty fast. Oh, 5 seconds, wow. So maybe we could solve it even using like segmentary or something, but we didn't need that. Okay. Anyway, this problem is, I don't know, crazy. Okay, so for all the let's find the number of splittings, not the number of double splittings. So for all the last five characters, 2, 3, 4, 5. For all these prefixes, no, I don't get it. I don't get it. So this is equal to the number of ways to take some string here and then add dp for this. And if we add a character here, we want to have these, right? So we don't need this character actually. We want 5 characters. And for all these 5 characters, we want to know these numbers. It's kind of bad because, yeah. So this is equal to sum of these numbers for all the positions where we are okay with taking this. If it didn't make sense for you. Where we can put a string here. So if this suffix is in the list. So we store 4 numbers for all the endings of size 4. Yeah, this number is not good, but probably it's better than that. I don't know. Wow. Okay, it's probably 8 to the power of 4. Yeah, it's 8 to the power of 4. So it's 5 multiplied by 2 to the power of 12. It's still huge though. Probably I won't be able to code it in these last 10 minutes. Yeah, people are sending out the problems. Yeah, it should be easy to solve them all, but I didn't manage to. Okay, let's see what do we have. Well, fine. Okay. Do we have like rooms here? No, we don't. Oh, it's educational. Oh yeah, it makes sense. Cool. Wow, that's insane. I don't know how to store it in like so we should create a matrix of size like n multiplied by n, and n cubed shouldn't be a big number, so it should be like size 100. So we should have a column of size 100 in which we have all the information we need, but this seems to be impossible. I don't get it. Because for me, it seems like we should have like all the characters for all the different characters and all the different pairs of endings. Okay, probably not like this. Okay, probably this can end here, and this ends somewhere over here. We should store the amount of no. It also should be like here. And then we add this, and if it's a good string, we can move it here. Yeah, something like that. Something like this. But it's really a lot, isn't it? We have like 5 multiplied by 5 multiplied by 8 to the power of 4 or something. The number of 4 digits, 4... It's a big number, I don't know. Okay, let's just wait till the end of the round, because I definitely won't solve it. Yeah, it was solved like kinda the same amount of persons solved this problem as the last one, but the last one seems to be super straightforward, right? You should just take a look at all the bits and find out what you should handle. I don't know, this F problem. Maybe I'm just bad at this theme and I should dive deeper into it. Accepted. Wait, what? I have one of the fastest solution here. How are they making it so... What? Why is it so slow? Maybe I don't get it. Maybe there is another solution to this, and I just don't understand it. So it's probably like n multiplied by this number x multiplied by log of n, right? And even then, we can say that x is like 18, and it's gonna be a little bit faster. Wow, why are these solutions so slow? I should take a look at them later. So we have problem F. Wow. 15 milliseconds. So the matrix should be like super small. But some solutions are slow. Well, I have no idea what's going on here. Wow. 15 milliseconds. There is a solution that doesn't use any memory. Well, that probably makes sense in this problem, but how to solve it? Wow. I have no idea. Okay, let's wait till the end of the round and see some solutions. And also here, well, I wasn't that bad. 5, 12, 20. Yeah, but this this seems to be better. I think I wasn't able to think while I was explaining. View the changes. Okay, that doesn't make sense. That doesn't make any difference. Yeah, I think it was hard for me to understand the problem while I was reading it out loud, and also it was hard for me to think about the problems while explaining them at the same time. So yeah, of course, first problem should be solved in 1 minute, and it took me 5. The next one, I struggled, but it seems like all the other people also kind of struggled with it, so it's fine. The next problem is, oh, is Codeforces even working? Probably not. Okay, let's see. CCPP. Oh, it's about colors. Yeah, it was also not that easy for me. I don't know. It took 8 minutes, but it's kind of the same for all the other people, so it's okay. This is about Euler cycle. I was really bad at it. Yeah. I should definitely learn how to do Euler cycles, because it's definitely my worst known theme in like basic competitive programming. I don't know how to do it at all. Okay, and problem E was about white cells. Yeah, it was really nice problem. It took us 22 minutes, well, and then we were solving this problem and this problem, debugging it, stuff. Okay, we're 25th. Cool. So let's find out what is going on with the problem F. Oh, we can't see the solutions of the people. Why? System testing? What does it mean? There are no system tests, no pre-tests for this kind of contests, I'm sure. Okay, it's kind of sad we're not in top 20, but whatever. How can I see the solution? Oh, yeah, now I can see the solutions. So let's go here This is the fastest solution available. It's hard to read. Why do you all have these hard templates? Damn. It's not aha, but a try? Okay, I probably should read the editorial. And what about this guy? What does he have? Probably he just made a huge matrix. Yeah, his matrix is like the sum of the lengths of the strings squared. Why do they... Okay, we'll read the editorial. Is it there already or not? Probably there isn't an editorial yet. Anyway, okay, let's see what's going on with problem G. And why do we have such a fast solution to this problem? So this guy has number of tokens and XOR sum of tokens in range. Is it sparse table? What? It's sparse table. XOR sum. What? He has sparse table? Why does he want to... What? Okay, I get it. Does he really need it? I don't understand the solution at all. Let's see some solutions that work long. Segment tree, yeah, he's got a segment tree. He's going... Segment get... C. C is equal to 9. Oh wow! Oh wow! That's so weird. Okay, I got it. But why would you do it? Wow. Okay, let's see something in the middle. I don't know, this guy. This guy, yeah. got a Fenwick tree. Okay, it's kind of the same as the segment tree solution. Wow. Okay, I should definitely read the tutorial for this contest, because I don't understand the solution of F, and I don't understand other solutions for J. But at the meantime, G without a vector. Oh, cool. Yeah, I was sure it's possible to solve it in O of NQ. Awesome, yeah. Yeah. Cool. So if you liked it, you can write a comment down below. If you didn't like it, you can also write a comment down below. I don't know, should I do it again or not? I think it was okay. So, bye. Goodbye to everyone. Thanks for watching this video. Take care.